Hello students, today we are going to learn about membership functions. In the last sessions we have seen about the fuzzy set and crisp set and what are fuzzy relations and crisp relations and what is the difference between fuzzy and crisp sets. Okay, so now basically how we are identifying the element which is belonging to the set or which does not belong into the set using fuzzy sets. So in classical sets, we'll just identify whether the element is even or odd, prime number or not, and directly we can say that. But coming to the fuzzy sets, we have to calculate the membership functions. The function which will find out the degree of that particular truth, like how much it belongs to the set, that is called as degree of membership, which can be calculated by membership functions. And these membership functions were introduced by Jede in the year of 1965. So if you see the equation, we are writing here A set A where x mu A of x. So this particular mu A of x is called as the membership function, which is used for calculating the membership value for the given element. Okay, so always you remember that this membership value will range from 0 to 1. Okay, in classical set it will be either 0 or 1, but in case of fuzzy set it will be from 0 to 1. So we'll see one example, then it will be easy for you to understand. 1 minute. Okay, so I'll open the open board. Yeah. Now, if I take this one, okay, if I take normal set, how we'll mention A equal to like 1, 2, and 3. Done. Now, coming to the fuzzy set. Okay, fuzzy set, how I'll write here? B equal to same element where 1. So what is the percentage? Membership value is 0.2. Similarly, okay, so here I'll write one more element. 2, it is 0.5, comma. So here also I have to mention the comma. Now, same, I'll mention 3 as 0.6. Close the set. So what we understood from here, so the general meaning of this one is the element 3 membership value is 0.6. And how we are going to calculate this 0.6 value using the membership function. So for any set, for any fuzzy set, the 0.5 and the 0.2. So these values will be get from your membership function. So what are the different types of membership functions and how we can use them in order to calculate this particular membership values can be done using this particular video. Now, okay, before starting this, please remember that these values will only range from 0 to 1 and including 0, 1. So I won't say that you have to exclude 0, 1. So no, you have to include 0, 0 and 1. Now, before starting this one, we have some of the basics of membership functions. So if you see here, first one is support. So what is meant by support? Okay, so remember that support is nothing but whenever you're writing the set, the membership value should be greater than 0. Okay, so membership value of this particular function should be greater than 0. Whenever when given set is called is given, so the membership value will be always greater than 0. So example, suppose how I calculate the support. So support will be always mu, okay, mu A of x. Sorry, 1 second. Mu A of x always greater than 0. If I take an example, I'm writing over here. If I take an example, our set A equal to, I have the values 0.2, 0.6. So what is the support of this particular set? Both are greater than 0. So your set value will be 0.2, 0.6. So this is called support. Okay. So what is the support? It should be always, the membership value should be always greater than 0. So that is one example for your support. So if you see the graph, it is always greater than 0. Now, next one, core. So if you see the formula over here, always the membership value should be equal to 1. Okay, so if I take the set of membership values, so if you see here it is 0.5 and it is 1. So always the membership value should be greater than 1, sorry, equal to 1. So that value is called as core. So we'll get the membership values 1 from your given values. So if that particular set is having 1, then it is called as core. Normality. So remember that always the core should be empty, non-empty. One second. I want to show one example. Yeah. Okay. What I said, suppose if I have one set A, all of you see here. Okay. A equal to 1 comma 0.2. Okay. One more is 2 comma 0.6. Okay. Third one is 3 comma 0.3. You can take any values. 4 comma 1. Now remember, when I calculate the core over here, what is the core here? 1. Okay, core should be 1. So what is the core value for this particular set is 4 comma 1. Done. But what about normality? Now, what is the difference between core and normality? Okay, just to see the example, then you can easily understand. Suppose if I take same example, A equal to 1 comma 0.1. Okay, these are tuples. 2 comma 1, 3 comma 0.6. Okay, now if you take the core value, so what will be the core value? So if I take core, only core I am telling. So core will be 2 comma 1. Clear? What is normality? Okay, I'll write here normality. Remember that core should not be empty. Okay, what is the meaning of that? At least one element in the set you should have one. Otherwise, it is not normality. Suppose if I take one set, here I have 0.2, one more is 0.3. These are membership values. Then I'll say that normality equal to false. Okay, because it does not have the 1 here. So this is called as normality. So just I'm briefing you. So when you talk about core, when you talk about the core equal to any element, you should have 1. Normality means compulsory the set should have the at least 1 core value. If that set does not have 1 core value, then it is called does not have the property of normality. Okay, so this is normality. Yeah. So we will say that the normality of A is false because in this graph, if you observe, there is not a single value have the core value. Okay. Now next one is crossover point. So what is meant by crossover point? So in any fuzzy set, okay, if you have a value as 0.5, so this particular 0.5 value is called as crossover point. So in the particular set, if you have 0.5 as a membership value, that point is called as crossover. Next one is fuzzy singleton. So singleton means it is just like core. Okay, I'll show you the difference. Then you can easily understand. 1 second. Yeah. First, we start with the core. Yeah. Okay, just I'm writing over here. Yeah. What is mean by core? Core means you should have the value as 1. Okay. Next, what is normality? Normality. If core is available, then true. Normality is true. Then what is mean by singleton? Okay, singleton. Singleton means only one value should be core because one value will have core. Suppose if I take one example, 1 minute, doing this. Yeah. So we'll work with the example, it will be easy for us. Yeah. Now, if I take if I take here a equal to 0.1 comma 1, okay, b equal to, these are membership value, remember that these are membership values, sorry 2 will not be there, that will be 0.2. Next c equal to 0.2 comma 0.3. If you take a, okay, if I take the set a, okay, now what happened? What are the properties? A equal to, yes, core is there, normality is true. Okay. If I take B, yeah, core is there, normality is true. If I take C, core is not there, normality is false. So normality is false. But what is meant by singleton? Okay, one more example I'll write here. Suppose if I take D equal to 1 comma 1. I have two values 1 comma 1. So this is not singleton. Singleton means only one core value should be there. We should not have more than that. So that is the difference between normality core and singleton. Okay. Next. So if you see the graph, it will have only one value, core value, that is called singleton. Now, alpha cut and strong alpha cut. So this is nothing but you will give some boundary value alpha. Alpha cut means this particular value should be greater than or equal to A. Alpha, this is, if I take strong, it should not be greater than, it should be, sorry, it should not be equal to, it should be only greater than this particular alpha. Okay. Now, convexity. So we'll substitute this particular formula, mu A of lambda x1 plus 1 minus lambda. So we'll give the lambda value into x1 and x2 will take 1 minus lambda into x2. So this will be, you're considering this value, always this should be greater than minimum of mu A of x1 comma mu A of x2. So this we will discuss in the next video. Okay, I'm stopping here.